All right, guys, I want you to meet Dr. Israel Tabak. He was one of the engineers who worked on Project Viking, NASA's mission to Mars, which landed 2 spacecraft on its surface in 1976.
Dr. Tabak, since we've been talking about geometry, can you tell me how geometry was used to get the Viking to Mars?
Oh, yeah, it's really relatively simple. You know, most orbits around the sun are fairly circular. So if we start from Earth, for example, and want to go to Mars, we use what's called a Hohmann transfer, which is an ellipse, which takes us from the Earth's orbit out to the Mars orbit, and we meet Mars when it gets there.
So if you shot directly at Mars, it wouldn't get there?
No, it'd go to the sun and heat up too much.
And that's the most efficient way to get there?
Yes, it is.
Less money, less time.
Smaller booster.
So Dr. Tabak, let us get this straight. Circles, ellipses, angles, geometry really helps with the navigation of spacecraft to Mars like the Viking.
All very essential.
Here's an experiment you can try at home with a responsible adult that will show you how curves and angles affect the path of a projectile. Have you ever tried to aim a dart at a dartboard? Pretend the dart is a rocket and the dartboard is Mars. Now, there are 2 variables that affect the results of this activity. If you throw the dart in a straight line at an angle of 0 degrees, gravity will curve the path downward, away from the dartboard, and you miss. But if you aim a little higher for the dartboard, or at an increased angle, you should hit the target. So, if the angle is one of the variables that affects this experiment, what do you think the second variable is? If you guessed speed, or how fast I throw the dart is the other variable, then you're right. The combination of speed and an increased angle determines whether or not I hit Mars. I mean, the dartboard.
What did the Viking mission accomplish?
Well, the Viking mission really consisted of 4 spacecraft, 2 orbiters and 2 landers. Viking was the first spacecraft to land on the surface of Mars, and we got some samples from the surface and found that the samples were all oxides, mostly of iron, and that's why Mars is so red, rust.
Now, how long did this mission last?
Well, we guaranteed it for 90 days, but it lasted for 6 years.
Well, it looks like Mars is a pretty cool place.
Yeah, it really is.
Dr. Tabak, thank you so much.
You're welcome.
We really appreciate you helping us understand how you use geometry to navigate to Mars.